Hey there, and welcome to the sixth section of this course, where we will learn about parallelism using streams and its various benefits over sequential computation. In the previous section, we learned about advanced operations for manipulating streams to achieve our desired results. The topic for this video is benefits of concurrent streams and concurrency in general, where we will learn about parallel computation, its benefits, and how and why we can create concurrent streams. Before we touch upon anything, let's begin with the concurrent computing. Concurrent computing is a form of computing in which several computations are performed at the same time simultaneously. Large problems oftentimes can be divided into smaller, independent problems that we can compute separately but at the same time and afterwards combining the results. The greatest benefit of concurrency is that when there are a lot of objects to be processed, it is much faster than sequential computing. As you know, Java provides the fork-join framework, which enables us to implement parallel computing to our applications. However, with this framework, you must specify how the problems are divided. With streams and aggregate operations, such as the ones we learned about in the previous two sections, the Java runtime performs this dividing and combining of solutions for us, meaning it eases our life quite a bit. One of the difficulties in implementing parallelism in applications that use collections is that collections are not thread-safe, which basically means that multiple threads cannot modify the same collection without creating memory inconsistencies or interfere in each other's work. The collection framework provides synchronization wrappers. These wrappers add automatic synchronization to an arbitrary collection, making it thread-safe, which, if you have ever programmed parallel code, you would know the pain of doing it yourself. Synchronization, however, introduces thread contention. Thread contention happens when two or more threads try to access the same resource. However, the Java runtime forbids this, and that makes the threads execute more slowly or stop executing at all. You want to avoid this because it prevents threads from running in parallel. Parallel streams enables us to implement parallelism without thread-safe collections. But you also must not edit the collection while you are operating on it, in which case you will encounter all sorts of errors you would rather not see. As you know, streams do not create memory consistency problems, because they are inherently functional. They do not edit the input, they simply take it and use it to create a different stream, which itself is functional, or they create a side effect, such as printing out the elements or returning a value. With this, we conclude the topic for this video, where we discussed parallel computing and concurrency, how it operates in Java, the differences from the fork-join framework, and why streams support concurrency.